Hello, everyone, and welcome to Clay Loves Logic, where on this channel I solve logic-based puzzles I find interesting. We've done a couple easy ones lately. We're going to keep that trend up with a quicker one tonight. I don't have a ton of time, so we're going to do a bit of a speed run here if we can, try to solve this quickly. It looks relatively easy based on the rules. It's got 260 solves in the last 12 hours. Tonight, we're going to be looking at the puzzle, but not a one to shoot by ark29. Let's start the puzzle, get into the rules. As always, I'll put the link to this puzzle in the description of the video so you can try it out if you'd like. Normal Sudoku rules apply. You have to have the digits 1 to 9 in every 3x3 box, in every row, in every column. Arrow rules. Digits on an arrow, sum to the number in the attached circle. 2-digit arrows are read left to right or top to bottom. So what that's saying is this one here would be the higher digit. So if you're two-digit numbers of 13, this would be the 1. Same thing here, 13. 1, 3. In addition, some arrows are whispers, some arrows are renbands. Along green arrows, adjacent digits must have a difference of at least 5. So normal arrow rules would say, if you have a 3-cell arrow in the same box, it has to be 1, 2, 3. This would have to be 6, which actually works for the renband and is probably correct. But we'll look at some other things first. This one here, this German whisper. What that's saying is if this is a 4, this would have to be a 9, and this could be, 1, 2, or 3, and then this would be the sum. Normal XV rules apply. Digits connected by an X sum to 10. Digits connected by a V sum to 5. Not all are given. That's going to be the start of the puzzle. Let's get into it. I'm just going to pencil mark in our 1s, 2s, 3s, 4s, 6, 7, 8s, and 9s. And immediately, there's a few different things we can do. For starters, what can this digit realistically be? Remember, you read the arrow sums from top to bottom, right? So this is the high digit of the two. So what if we absolutely maximize this and we say the biggest this could be is a 9. The biggest this could then be is a 4, which would give us 13. Well, the biggest this could be by German whisper rules, it has to be at least 5 away from a 9, and it's not a 4, so it's a 3. The biggest 3-cell this sum could be is 9, 4, 3. And 9 plus 3 is 12, plus 4 is 16, right? Yeah, so if we absolutely maximize this, we get 16, which means this is always a 1. That's our first digit, which actually gives us our first few digits. This is a renband, and it's also an arrow. So this is 3 or 5, and that forces this to be 7 or 9. Okay, let's look down here, because this is a renband and so is this. These 3 digits have to be adjacent to each other. So your only options when they have to sum to something is 1, 2, 3, giving you 6, or 2, 3, 4, giving you 9. Both are valid. But imagine this is 2, 3, 4. Then you have to have 2 digits that are adjacent. 5, 6 would sum to 11, which we can't do. So in fact, this is a 1, 2, 3, which gives us a 6. This is a 4, 5, which gives us a 9. 4, 5 eliminates this ability to be 4, this ability to be 1. This digit's on a 1-cell arrow, so this digit and this digit are the exact same. This has to be German whisperage, so this is 7, 8, or 9. And then this is 1, 2, 3, or 4. Because, again, this could be 4, 9, 3. This could be 3, 9, 2, anything like that. But again, doesn't the same logic apply where if this is absolutely maximized with a 9, a 4, and a 3, it can still only be 16. So then this is always a 1, isn't it? And that is going to give us a 2, 3 pair here. So that's going to give us a 2 or a 3. Okay, a German whisper that's 2 cells, that's not 2 or 3 is either, well, first of all, the low digit is either 1 or 4, and it's never 4. So there's always a 1 on this. And then a 1 can go with a 6, a 7, or an 8, or a 9. It can't be a 6 because there's a 6 in the 3x3, so it's 7 or 8. 9 would be valid, except remember, this is on an arrow. These have to sum to the same thing. So if this is 1, 7, you get 8. If it's 1, 8, you get 9. And those are the only options it has. Okay, where should we turn our attention to next? Well, this can't be a 4 anymore, because if this is a 4, this is a 9. There's a 9 here. So that's not a 4, and that is not, in fact, a 1. Oh, further too, look, what did we say about this? Where if this is, 1, 2, 3, or 2, 3, 4 to make 9, well, look at this. This has to be 2, 3, 4, and that can't be 4. And in fact, this is a 1, 2, 3 triple. So this is 4. This is now 2, 3 to get to 9. We have a 2, 3 pair now. That's interesting. And that means, well, where do we put a 9 in here now? 9 is just there, which gives us a 9 somewhere here or here, which we already, is possible. Okay, here we have German Whisper, right? Now this has to be 6, 7, 8. In fact, it can't be 6. If this is 6, you'd have to have 1 on either side. So this is not it's not a 6. It's a 1, 2, 3. And that gives us a maximum, because again, it does have to be at least higher than 10. It has to be at least 11. So it 7, 3. Actually, this is an 8 now, isn't it? Because it has to be bigger than 10. So if you could have 7, 1, 3, sure, that gives you 11. But 7 is not valid with 3 on the German Whisper. So the only way to get this to be high enough is if this is an 8. And this is now a very small, total. This is either, well, let's think. If this is 8, 3, 2, we get 13. So 8, 3. Oh, and we can't have 13, can we? Because if we have a 3 on this, if this is 3 and 2, it sums to 13. And then we'd have to have a 3 here. So it's not 3, 2. If it's 3, 1, it's 12. 12, that's valid. If it's 2, 1, 8, 9, 10, 11, 2, 1 would give us 11, and we'd have to have double ones here. Is that the only way that works? Let's think about that. 8, 1, and 2. That gives us 11. 11 doesn't work. 8, 1, and 3. 12. 8, 1, 3. 12 works. 8, 1, or 8, 2, 3 doesn't work, does it? 8, 1, 2, 8, 10, 11. Yeah. 8, 2, 3, 13. Yeah, it doesn't work. This is just a 2. So this is a 1, 3 pair. 1, 3 removes this ability to be 3. This is either 2 or 4. That gives us a 5, which is going to give us a 9. And that is, oh, and this is a 9 because of this 8. So that's interesting. What do we say now? What about this? We need to have a 1 on this now, don't we? Because 2, 3, and 4 are all spoken for. So we need a 1 and a high digit that could be 6, 7, or 8. 1, 2, 3, 4. We need a 5 somewhere over here, possibly down here. 5, 6, or sorry, 5, 8, 9. What else? 7. 5, 7, 8 up here. 5, 7, 8, 9. That's going to be that composition. Over here, what do we need? 1, 2, 3, 4, 5. We need 6, 7, and 8. And that is it. Oh, and a 6, 7, 8 triple. We get a 1 now, don't we? That's nice. So that's gonna, and of course, you know what? We knew that because we always had to have a 1 down here. This just always had to have a low digit. Okay, what about a German Whisper here now? Do we know anything about what this can be? If we think about a German Whisper that's, it's a German Whisper that has to sum to something. What can the low digit really be? It could never be a 4 because 4 can only go to 9. Not only is 9 spoken for, but that's way too high of a digit. If it's 3 and 8, that's too big. 11. 2 and 7 works, right? 2 and 7 would be 9, which is valid. Now it's going to just be the same composition, isn't it? Where it could be 1, 2, 7, or 8, but this is not the 8. And that's going to be all it has the option of being. Okay, let's think about this. This is a huge one. Well, no, let's do this again now, because look, these 3 cell ones, they're either only ever 9 or 6, and it sees a 6 right there. This is a 2, 3, 4 triple. It's only option. That's easier. And of course, this is not a 4 because of this 4. And that's that. And I will tell you something else interesting. If we think about this, I'm sure. No, I won't. I'm not sure yet. And I guess this could be an 8. What about this? Can't be a 6. A 2-cell Ren band, 2 digits that have to be together. Oh, and look at that. It can't be 1, 2, or 3 down here. So i.e., this digit has to be at least This digit's at least 5, isn't it? So it's only ever 5, isn't it? 1, 2, 3, 4. This is a 5. And it goes next to a 4, and it gives us a 9. That actually just gives us a 5. That's just now the only option to have a 5 in this row. So now we have a 7, 8, 9 triple. Okay, what are these now? These are only 2, 3, 4, 5, 6, and 7 that don't resolve. Oh, they do resolve. This is a 7. This is a 6. This is now a 7, 8 pair. A 1, 7, 8 triple. Okay. Great. It's a fun little puzzle. Now this one here, this is interesting, right? Because we know that 9 cells in the same box row or column of Sudoku have to be the digits 1 to 9, right? It has to be the triangular number of 9, which is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. It's 45. So when you have this kind of setup here, where these digits equal 45, but these digits equal this, then we have this setup where 45 less this equals this, don't we? So what could it be where 2 cells of the Sudoku, because I don't know if I'm explaining this correctly or if I'm what I'm saying makes sense, but this equals 45, but 45 minus this equals this. And what I mean is the value of these 2 digits. So let's think about that. Again, what's the biggest this could be? 1, 2, 3, 4. We can work through this pretty quick. This could never be 4. Because if this was 40 something, the lowest it could be is 41. And if it was 41, that would mean all of these digits sum to 41, and these 2 digits would have to sum to 4. Yeah. I hope I'm explaining it correctly. It makes sense in my head. If this is, well, this could never be as low as 11, right? Because another way to think about it is you add the total of this. If these 2 digits sum to 12, then all of these digits have to sum. This couldn't be as low as 1. I really hope I'm making sense of this when I'm explaining it. It makes sense in my head. Again, this, right? What is this? Could this be 2? Because what if this was 29? All of these digits sum to 29, but these 2 digits would only have the value of 11. 2 plus 9 is 11. 29 plus 11 is nowhere close to 45. This has to be 3 something. This just has to be a 3. But what could it be? Right? Because now what we're saying is this 30 something has to sum to a situation where what if it was let me just pick a number. Let's say this is 31. Then these digits all sum to 31 because they have to, but then you can only add a value of 4. And it needs to sum to 45. So it needs to balance. And I think that just means this is a 6, right? 45 minus 36 is 9, and these 2 digits sum to 9. That's the only way this makes any sense in my head. That just has to be correct, right? Because if all of these equal 36, then you have 36. But you have to get to 45 in the box, and you can only add these 2 digits. These 2 digits have to sum to something. When added to this, you get to 45. That's the only way it works. This is a 2. This is a 4. This is a 3. I hope that makes sense. I don't know if I did a very good job explaining that, but that makes sense to me. That's going to give us a 9 here by Sudoku, which is going to give a 9 here, which is going to give a 7 here. Remove the 7 from this. That's an 8-1 pair. It's going to give us an oops, 9. This is an 8. This is a 7. That's all well and good. What is this now? 1, 2, 3, 4, 5, 6. This is a 7. What are these? We need a 2 up here somewhere. 4, 5, and a 6. That is resolved by Sudoku. 6 and 2. Up here, we're going to need a 3 there by Sudoku via this 3. 1, 2, 3, 4, 5, 6, 7, and an 8. Okay. What can I tell you now is that these are both 3s via that 2. It's going to give us 3, 2. That's going to give us 1, 3, 4. We can now remove, 3 and 4 from here. This is only 1 or 2. This is never a 3 anymore. Where does 1 go? Basically anywhere. Well, what is this now? Let's ponder that instead. This so far is 13. If we add 1 to it, it's 14. If we add 2 to it, it's 15. And it can't be a 14. So this is 15, which means this is 2, which means there's no 2 on this anymore. So the low digit is always 1. What do we need here? Now we need 6, 7, and 8. This is a 7 by this 7 Sudoku. This is now a 6 and an 8, which gives us a 1 by Sudoku and an 8. And now it gives us a 1, removes those ability to be 1. This is now a 1, because this is not. This is still 7 or 8, which is still fine. This is a 5 and a 4. This is not a 1. This is not a 2. So this is, in fact, a 1. And we have a 2, 3 pair. We have, this is a naked single. 1, 2, 3, 4. This is just a 5, isn't it? And then this is now 1, 2, 3, 4. That is going to do a 4 here by Sudoku. What do we need here? 1, 2, 3, 4, 5, 6. We need a 7 and an 8. This is the 8. This is the 7. Down here, we need a 2, which is going to live here. 1, 2, 3, 4, and a 5, which is going to live here. This is an 8 by Sudoku. This is now 1, 2, 3, 4, 5. This is a 6. This is not a 6 anymore. This is now 1, 2, 4, 5, and 7. So via Sudoku, we get that. This is not an 8. This is not a 7. This is now, actually, it's not resolved yet. Okay. What are these 3 digits? These are from, we need a 1 somewhere here, so that's the 1. We need a 2, which is here, and we need 5, which is here. In the middle, we need a 3. Not resolved, one of 2 places. We need a 4 somewhere over here, is resolved. We need 6 somewhere. Surprisingly, a few options. We need a 7 somewhere. Couple options. We need an, I can just put a 9 there first of all, thanks to math. I got distracted there. Now we need an 8 somewhere in one of 2 places. Whoops, I meant to pencil mark those. Right, because that's a 6, 8 pair. We have an 8 here, we have an 8 here. So 8 is only ever here or here, which means this is an 8. This is a 6. Is this a naked single? Of course it is. 6, 7, 8. Pencil mark 6, 8. 2, 3, 7, 3. And then 2 and 3. Great. 19 minutes, 1 second. 264 people have solved that in the last 12.3 hours. Great puzzle. ark29. But not a 1 to shoot. I hope everyone enjoyed that. We'll see you on the next one.